In this video, we are going to continue our discussion of section 13.1. This is multivariable functions. We are going to work on graphing some of these. So we're going to start, I gave you three steps for this. Set the function equal to z, and then manipulate it, right? Change it to be something that you recognize. If you can't do that, then use a computer. We don't want to too long. There's a lot of functions that are totally not doable by hand. I will show you some at the end of this section. So let's start with graphing. So f of xy is our z. So we have that. I'm going to manipulate this now I'm going to bring 2x minus 3y plus z, and hopefully right now something triggered. That is a plane, right? So we have a plane in 3 space, right? I'm going to show you the easiest way to graph a plane, and it's done by intercepts. Remember, in 2 dimensions, if we wanted to find the x-intercept, we would let the y equal 0. So in 3 dimensions, if I want the x-intercept, I let the y equal 0 and the z equals 0. So I get 2x equals 6, so I get x equals 3. So I'm going to go to my x-axis that is here, and I am going to plot a 3. You may need to draw that. Okay, y-intercept, I let x and z go to 0, so I get negative 3y equals 6, which means y equals negative 2. So on the y-axis, I'm going to plot a negative 2. And then the z, if I let x and y be 0, I get z equals 6. This is 6 up here. I think 3, yep, 6. Okay, so what I do now is I know this is a plane. I'm going to use these 3 points because remember, okay, to make a line, I need 2 points. To make a plane, I need 3, as long as they're not collinear. These are not collinear. So I draw a line connecting these two, and then the other 2. So you're connecting all points. And if you notice, if I shade in that area right here caught between, oh, I'm shading with white right now. All right, if I shade all that, I'm going to do that. Try to stay in the lines. Yours doesn't have to be pretty. This is something I definitely could ask on a test. This question is totally doable. The graphing's not too bad. So if you notice there, I have filled in a plane. It's caught right there in that quadrant, right, in the octant 4, or quadrant 4 if we were in 2 dimensions, only considering those. But it's stuck there, but it extends past. We just captured where it lands, like it goes on. It's like catty-cornered infinite plane, but that's where it intersects that octant, right? That's the only place in that octant that plane is going to be. So we have captured the slant of it. We can see the plane. We can visualize it. This is the quickest, best way, I think, to graph a plane. All right, let's lead on to things that aren't so straightforward. I changed this in your notes. They should be changed. The reason I did that is just for graphing sake. This is a 3D graph and then a 2D domain. We can tell because there are 2 variables. We add 1 to get our graph. We keep it, right? 2 variables means that the domain is 2. This makes sense because you're trying to figure out what x and y's can be. So I take this thing, I set it equal to z, 4 minus x squared minus y squared. I can factor that x squared plus y squared out for the negative, and then I can just add it to the other side. Actually, yeah, let's add that to the other side. X squared plus y squared, that becomes a positive, and then I'm going to minus z to the other side. Now, this may not be obvious because I know surfaces are difficult and they're very tough to memorize, but this is a paraboloid along z, because z is the first power. We got a plus here, so that's why it's a paraboloid, not a hyperbolic paraboloid. Opening, and we don't want to use up or down because we're in 3 dimensions. Kind of hard to determine which way is which. So we'll say opening towards negative z. And then also this shifts plus 4 on z. Okay, so I just use the standard shape. I know it moves up 4, so I'm going to plot 4. I also know that when z equals 0, we get x squared plus y squared equals 4. That's when z is 0, that's flat. So I get a circle with radius 2. So I'm going to go ahead and draw that. I'll use a dotted line to represent the 3D-ness. right? And then we get a paraboloid. So mine never look great, but it's something like, oh, no dotted line. Maybe on the back side we will, but something like this, right? And I try to make it smooth like a parabola on top. It's very difficult to do. Also, I'm just not a great artist. Something like this on a test, like if I had you graph like this, then it would be met with tons of grace, and I would be looking for certain characteristics. So we get something like that, and this goes out. So we get a parabola shape down. It's going up 4 because of the plus 4. This negative makes it, the plus 4 shifts it up 4. The negative makes it go down. If it was a positive z, it would go up. Okay, so there's our paraboloid. All right, we have a few more. The deal with this is, hopefully at this point, and I know by the time you watch this, the testing is going to be over with. There was no graphing on exam 1. I do that on purpose. They're pretty difficult to graph. So with this, there could be some graphing with this exam, but I will try to keep it really tame. So, yeah, so just work on your homework problems. So the point of this, where I was going, and I went off on a tangent there, was this looks like something crazy that we haven't worked with before. But if I keep working, let's do this. So I'm going to change that to a z, and I'm going to manipulate my equation until maybe I see something familiar. All right, well, I know that this 1/2, I can move that. It's 2z. And I still have all this, 36 minus 9x squared minus 36y squared. Now I can square both sides, so I get 4z squared. 36 minus 9x squared minus 36y. I just got rid of the things that are unfamiliar to me. I'm not used to seeing square roots with surfaces, so I got rid of it. So now notice, if I bring everything with the squares on the right side, those become positive. And I leave the 36 there, but now I'm going to divide by that 36. Maybe you can see where we're going. And we actually now land at something that should feel familiar. This, we're not going to graph it, but this is an ellipsoid, right? And we have the a squared, b squared, c squared for the, like this has 2 in the direction of x, 1 in the direction of y, and 3 in the direction of z, right? For the axes, and then we draw that bean looking thing or football looking shape. All right, we're not going to waste our time graphing it because you guys have already done that. I'm going to end the video here. So the point of this is set it equal to z, manipulate it until you see a surface that you're used to. If you can't, then it's a graphing on the computer thing. That won't happen on a test. That would be very cruel of me because you're not going to have a computer. So get some practice under your feet for this one.